September 30th, 1968. Just 16 months after production began, and with the banks closing in, Boeing revealed their 747 to the world for the very first time.
I think for anybody who was present when the 747 was rolled out for the first time, it would have been astounding, really. The size of it, compared to the aircraft that had gone before, at least the commercial aircraft that had gone before, was absolutely extraordinary.
In debt by over $2 billion, Boeing desperately need this unveiling event to capture the world's attention. But behind the publicity stunt lies a potentially devastating problem.
When they unveil the prototype, the world goes nuts. It immediately gets this nickname of the jumbo jet. Everybody thinks it's amazing. You'd think now, like, finally, they've done it. But actually, they haven't at all, because the thing they're showing everybody can't fly.
The engines attached to the prototype don't work. Despite successfully designing and constructing this wide-body, high-capacity plane, Boeing have yet to figure out how to actually get it into the air. And it's not a problem they can fix themselves.
Boeing, they know how to make airplanes. The one thing that they don't make is engines. And in the history of aircraft, the problem usually isn't having a good airframe, it's having enough power to get it off the ground. And in the case of the largest airplane the world has seen up until that point, they're going to need a lot of power to get it off the ground.
With an unprecedented 735,000-pound takeoff weight, the 747 requires a huge increase in engine power and range for long-haul flying. So Boeing team up with Pratt & Whitney, innovators in the field of aviation propulsion, who are working on an experimental new engine design that promises to revolutionize commercial air travel: the turbofan. The turbofan engine is an advancement of the more traditional jet engine.
So the original jet engines from World War II that were developed in England and in Germany were called turbojet engines. They have basic components. There's a portion with fans that compress the air. Then you add fuel and combust the fuel-air combination. You then have turbines that extract some energy from that combustion to run the compressor blades, and then you have some kind of exhaust to create the thrust. So conceptually, it's very simple, but then it's limited to, well, how much thrust can you get depending on the size of the aircraft?
The first turbojet engines on the Boeing 707 produce 11,000 pounds of thrust, whereas the 747 is going to need almost 4 times that amount.
So the idea with a turbofan is to increase power without increasing your fuel consumption. So in the middle of the engine, you still have the classic jet engine. You have compressors, turbines, combustion chamber, but at the front of the engine, you now have this massive fan. And that fan is sucking in even more air. And the genius behind the turbofan is it's taking air that's not being heated up, it's just speeding it up. So as the engine's spinning in the middle, this big fan at the beginning is not just feeding the engine, it's taking more air and compressing it, speeding it up, and putting it around the outside of the jet flow.
The addition of the gigantic fan means air is sucked in at a rate of 885 feet per second.
So it's the sheer speed that the air is traveling through just generates extra thrust without the need for a bigger engine.
But in 1968, this new engine design is in its infancy and has never been tested on a commercial aircraft.
Pratt & Whitney are designing a whole new type of engine for this. It's a turbofan engine called the JT9D, and they are having an absolute nightmare getting this engine to work.
It's one thing to invent the technology, it's another thing entirely to make it reliable enough to use it on a civil aviation setting. There are a huge amount of glitches to overcome. Little things like distortion on the casings or blade failures, the compressors not doing what they were supposed to, and that hurdle for them to overcome was massive.
But time is running out for fixes, and the pressure is mounting on Boeing. They have to push forward with the test flights and start recouping their considerable costs.
So what they have to do is cross their fingers, slap the engines they've got on, and hope that nothing bad happens, which, again, all of this is being driven by the fact that they need to start recouping money as soon as possible because they're literally living on the edge now, Boeing.
On the 9th of February, 1969, the 747 made its first flight. It was taken up by Jack Waddell, who was the test pilot, and it was being watched by a large group of people. So it was important that it went well, and actually it didn't go well.
In front of the world's press, Waddell taxis the untested jumbo jet out onto the runway for its maiden flight and executes the perfect takeoff. But once out of sight, there's a problem.
As he's flying, something's going wrong. He can feel it in the controls. One of the flaps, it's loose, it's broken. The plane is in danger, and it's not just the test pilot danger he's used to. His employers, his customers, all of them could lose faith in this new plane all at once.
So they have to bring the aircraft back very quickly to make sure that there's no lasting damage to the one 747 in the world that everything is resting on.
Landing a plane of this size comes with its own set of engineering challenges, and they're about to be put to the test for the very first time.
And as this aircraft's coming in, it has less flaps, which means it's coming in slightly faster than they want it to. So as they touch down, everybody holds their breath.
Against the odds, and to everyone's relief, Waddell expertly guides the jumbo jet into a smooth landing. The test flight appears to be an aviation triumph. But in reality, the 747 is still far from being safe to fly.
Normally these days in modern engineering, we do a lot of modeling, so we do a lot of simulations, so we kind of know what's going to happen before it does. When this was being designed, they didn't have that capability. Things were very much like, let's move this, let's change that, let's add this material, let's change this material, let's change this temperature, this speed, and see what happens.
After months of test flights and modifications, Pratt and Whitney eventually solved the fault within the turbofan engines by stiffening the casing to strengthen the blades. But for Boeing, the problems keep coming.
During test flights, one of the things that was being noticed by the pilots was that these enormous wings on this aircraft were prone to something called flutter.
Aircraft wings are deliberately designed to flex so they can absorb energy caused by air turbulence. But that flexibility can also lead to other issues.
Flutter is when you have these aerodynamic forces on your wing, as well as the inertial force of the aircraft going forward.
When the air flowing over the wing makes it bend excessively, the resulting change in airflow pushes the wing back in the opposite direction, creating a feedback loop that leads to vibrations, known as flutter. This motion can continue to grow to dangerous levels.
In really extreme cases, as flutter causes the wing to wave, the whole wing can completely break off.
With the 747's wingspan of over 195 feet, any amount of torsion can quickly be amplified. To spot the problem and fix it, the aircraft must be pushed to its absolute limits, and only a select few are up to the task.